Okay, so wait a while. Okay, so we move on to study lecture 2 of session 5. All right. I hope all of you can see this PowerPoint slide, right? So lecture 2 of session 5. So you remember in lecture 1 of session 5, we have studied the working principle of 3 popular type of electric motor, right? So we understand the mechanical aspect of this electric motor and also electronic aspect of this motor. And now we try to understand how to attach these 3 types of motor into IoT. Because remember, inside the Internet of Things, 2 important devices should be sensor and actuator. But of course, behind sensor, behind actuator, there must be microcontroller, right? So with the use of a microcontroller, we are able to build up a 2-dimensional IoT or 3-dimensional IoT. And with the use of the same microcontroller, we are able to attach 12 sensors to each node inside the IoT, all right? Now we try to see how many actuators could we attach to each node inside the IoT, which make use of an ARM microcontroller, right? So we first look at the way how to interface stepwise motion actuator inside the IoT with the use of ARM microcontroller, right? Okay, so we move on. So in case if you do not see the advancement of the slide, you must inform me, right? So, okay, I assume now you can see the outline. Since we just finished the study of lecture 1, I guess for the first item, I can just quickly go through. Okay, just a quick reminder for you. Okay, in terms of a number of phase, right? Single phase actuator refer to continuous motion actuator without the brush, right? And the 2-phase actuator refers to stepwise motion actuator, and 3-phase. Okay, just now is wrong. So single phase actuator refer to continuous motion actuator with a brush, right? And the 3-phase actuator refer to continuous motion actuator without the brush, right? Then for stepwise motion actuator, basically they are 2-phase actuator, right? So, and in lecture 2, I just explained to you how to make use of GPIO. GP means general purpose. IO means input output to achieve the supply of a control signal for stepwise motion motor. Okay, but keep in mind, GPIO also allow you to control continuous motion motor with the brush or without the brush, because from the number of a phase of a point of view, actually they are the same, right? Because we can talk about single phase actuator, 2-phase actuator, and the 3-phase actuator, right? If you know how to control 1 phase, you should be able to know how to control 2-phase or 3-phase, all right? And in lecture 2, we look at the situation of controlling 2-phase actuator, which are stepwise motion actuator or motor, right? Okay, so this knowledge are equally applicable to the case of a continuous motion motor, right? Okay, so this is just a quick overview about what you have learned in lecture 1 of session 5. So now you remember stepper motor are considered as a two-phase electric motor, right? So we have a phase 1, okay, use this terminology. We have a phase 1, phase 2, and phase 1 has a 2 terminal for connection, 1A, 1B. 1A could connect to positive power or to the ground, and the 1B also could connect to the positive power or the ground. So this is why each terminal, 1A or 1B, must have one pair of switches to do the logic control. So therefore, you have 4 electronic switch for one phase. Let A together, you must have A electronic switch, all right? If there's a hardware support, then we just need to provide 4 signals. If there's no hardware support, purely from microcontroller, then we need to provide a digital signal. That's it, all right? Okay, so that is a basic knowledge, all right? So this is why you see we need to have 4 switches for one phase, because each phase has a 2 terminal, 2 connection, all right? Each connection need 1 pair, right? Then in this case, okay, one phase need 2 pair, then total 4 pair, all right? So that gives you idea, right? And for stepwise motion, remember, okay, we can, okay, move for 1 step, then stay there for a certain amount of time, then move another step, stay there for another amount of time. But this can control by the width of the pulse. You see, we have a positive pulse, okay? We can control the width, the timing, okay? This is the signal 1 will last for how long, okay? That correspond, okay, the duration of the motor in one rotation, in one orientation, and stay there for how long, right? So these are the simple concept. Once you know this, actually, conceptually is quite easier, right? So for one signal line, I just control on, off, let's say 0, 1, 0, 1, okay? 1 for, okay, certain duration. The duration is required by your application now, right? Let's say I stay there for 10 milliseconds, that's it, all right? So in terms of a control of the stepper motor, okay, from the requirement of supplying digital signal is quite straightforward, right? Just provide logic signal 1 for certain duration. That's it. All right. Okay. Then how many such a signal just now I mentioned with hardware support 4, without the hardware support A. That's it. All right. Okay. So now, if let's say we use a GPIO, general purpose IO. Okay. This is like last week I mentioned, you pay a price of a bicycle, you get a sport car. Okay. Because the GPIO means what? You can use this to interface with anything. Eventually, you can use GPIO to implement serial communication as well, like synchronous communication, asynchronous communication, all right? If you are skillful enough, that is for you to know this, all right? But of course, for some user, you don't want to study the detailed implementation of synchronous, asynchronous, or PWM, or reading the data like a QEI or whatever, all right? So this is why you use dedicated IO or special IO, okay, or SIO, special purpose or SPIO. So besides the GPIO, all the rest could be named as SPIO, special purpose IO, like a synchronous, asynchronous, all right? So I use this opportunity to expose to you the presence of a GPIO in every microcontroller. They give you this one. So actually it means what? If you are good enough with GPIO, you can do whatever you want already, all right? So this is very interesting to you. But remember, GPIO can also be used for you to control all the motor, not 2-phase motor, also 1-phase motor, 3-phase motor, all right? But I'm not going to repeat in the lecture 3. Lecture 3, I will expose you to the special purpose IO dedicated for the generation of a PWM, okay? So you think in this way, therefore, then you have a full coverage for your study. Then that means you have learned everything already, all right? Okay, so why do you use our microcontroller? strong reason is to build up IoT, right? So inside IoT, we must have a connectivity in 2-dimensional space, 3-dimensional space. And also inside each node, we may have automated control of sensor, actuator, or any machine, all right? So because we can implement a feedback control loop, because we have a sensor, we have an actuator, and the node itself is a controller. Then you see you have everything, right? So IoT is very important. For those of you, if you have a friend doing the study in medical school, you can ask your friend, actually our body, human body, because I spent 1 year to study in medical school, right? Also, I teach robotics, automation, sensor, artificial intelligence. Remember, I spent 1 year to do self-study in the medical school in Singapore. Then I discover our body nervous system. Actually, our nervous system is IoT already, all right? How come we can control the muscle? And it's a feedback control loop. Okay, this is just extra information for you to know. If you are interested in, you can do self-study, okay? For the year 1's courses in medical school, then you understand our body. Our body is a massive network of IoT, all right? Just for you to know. This is why IoT is very important, because our body is also a massive network of IoT, all right? Okay, then to how to use microcontroller. So this slide I add in some extra information in case for those of you, if you do not have a computer science, computer engineering background. Your role is a user. User means you know your program, you know your problem, you know your solution. Then you just need to have a machine with a brain to implement your solution, all right? Then your role is a user. As a user, actually your role is like a director of a show program, all right? Application is like entertainment. You demonstrate a show. And if let's say you have a smart machine or a IoT to demonstrate application, application is like a theater, entertainment theater, to demonstrate a series of a show, right? And then what is a show? Show means that you have play the game, a series of a game, and each game you can consider is one or a group of a player. Okay, under the direction of one instructor. Then this is easier for you to understand. Okay, so one instructor with 1 or 2 or 3 players just play a single game. Then in computer science terminology, we call this is an instruction. So inside the instruction, you have a code. That means the game. What is the nature of the game? The simple game could be do addition is one game. Do subtraction is another game. Do multiplication is another game. Shift the data from one location to another location is another game. Just think in this way, all right? So one instruction is one game, all right? If you have many such a game, you put together, then you have a program or application or demonstration, all right? So your role is just to, as a director, okay, I want to present a show to the public, then I have a series of a game, all right? But in computer science terminology, it means I have an application. This application could be implemented by series of instruction, all right? Then in the case of IoT, one instruction is reading the data from sensor. That is one game, okay? Reading the data from the sensor. Another game is send the control signal to actuator. Let the actuator to make an action, take one action, all right? If you have a lot of sensor or series of data to get in, then you have a sequence of instruction for reading data, sequence of instruction for actuator to perform action, rotate how many degree, how many steps, something like that. So it's very easy. Your role is like a director of a show program, all right? A show program is a series of a game. Each game is one instruction. Inside one instruction, you must have an instructor. The code, operational code, just imagine is an instructor. And the data is just consider, or value symbol, consider is a player. So instructor tells the player what to play, all right? And some player may be stored inside another address or memory. So you know the address where to find the player. You see instruction have a code plus address plus value, all right? Value itself the player. And sometimes you can get the value from another location, not directly near you, near the instructor, right? So this is address from which, okay, you get the value, right? That's it. Let you understand in this way, you know your role already, okay? So I provide this extra information to help those without the computer science engineering background, okay? So it's very simple. To write the program is similar to prepare a stage show, okay, inside a theater, right? So as a user of application is similar as the role of being director of a show program. That's it. And each instruction is one game. That's it. And inside one game, you have a one instructor plus few player, right? The instructor correspond to the operational core. That's it. All right. Okay. Very simple. Then once you are excited about the power, beauty of a microcontroller, then you can venture into the study in detail about the microcontroller. So basically, there are two parts for you to study in microcontroller. One is about the programming, okay, how to program microcontroller. Basically, just now I already mentioned to you how to write all the instructions, put them together in order to implement your application, such as reading the data and send out the control signal. These are the simple games, all right? Okay. And the second one is to interface your brain or machine's brain and microcontroller with a sensor, with the actuator, all right? Or with other microcontroller to build up the network, all right? It's just doing programming interface, that's it, right? And for interface, you have an input device. Typical example should be the sensor. Output device, typical example should be the actuator. So today, basically, we play with the actuator, right? Then good news is how to play the game as an instructor or as a director of a show program is very simple, okay? So you just move out the data among the register. So you just configure the system, all right? So based on your intention, how you're going to play the game, all right? And in this case, in today's lecture, the game is to send out the control signal, all right? Let the actuator to response, all right? Last week is to read in the data, okay, to know what happens in the outside world, all right? That's it, all right? But of course, you can also play the game, such as doing addition, subtraction, etc. Right? But that is not for this interface, right? For interface, this is just to control, okay? Input data from a sensor, output control signal to the actuator. You just need to have this skill, okay? So as a user, it's quite straightforward, quite simple. All right. Now look at the GPIO. GPIO means a general purpose IO, means what? With this support of the hardware, you can do whatever you want, all right? Including all the functionality of a special IO, special purpose IO, all right? So that gives you full power of this microcontroller. That means it exposes you full power of the microcontroller, right? So then keep your mindset, okay? Like what I recommend you to think, okay? You pay a price of a bicycle, you get the sport car, okay? Think it this way, then you will not get lost, okay? So then you see, so cheap the price for this device, and so powerful is this device. You see, you have a 6 port, all right? Port means is the pin in which you can read in the data from a sensor or output control signal to your actuator. Each port corresponds to the byte. You remember in computer science engineering, the basic unit of a memory is a byte. One byte has an 8 bit, and each bit corresponds to 1 pin in hardware, all right? So then for ARM microcontroller, they give you 6 port, each port has an 8 pin. Now, in theory, you may have a 48 pin. 48 pin allow you to output 48 signal or read in 48 signal, but they will take out the 5 for special purpose. Therefore, as a user, you have a 43 pin already. All right. So then if let's say 2 pin for you to control 1 phase, then how many phase can you control? At least 21, you know. So 21, how many motor are there? There's a single phase motor, then it's 21 motor. 2 phase motor is 10 motor. 3 phase motor is 7 motor. Yes or no? 21 phase. Okay. You can control 21 phase. For 3 phase motor, that is a 7 motor already. For 1 phase motor is 21 motor. For 2 phase motor, that is a 10 motor. Now you see the power. This is very cheap. So it's like what I say, you pay a price of a bicycle, you get the sport car. Now you believe it, right? Okay. So that will make your study a little bit difficult. Wow, 20 motor, 21 motor, all right, 10 motor, 7 motor, all right, make me headache because I say, I just want to control 1 motor, all right? So it's like you get the sport car, but you can still drive it at the 1 kilometer per hour. Don't drive it at the 200 kilometer per hour, all right? So you must be happy, okay, with such a potential, all right? Okay, so that's just for you to know the number of a pin, all right, is a lot, all right? Okay, you can control a lot of things. Then where are these pins? So this slide help you to understand how to do the hardware connection. You see, let's say pin number 1 of a port D is here, pin number 2 of a port D, pin number 3 of port D. This is just for you to know how to read all these things, right? Then you follow this table. Let's say for port A, you have a pin 0, 1, 2, 3, 4, 5, 6, 7. But on the chip, what is corresponding pin is 17, 18, 19, 20, 21, 22, 23, 24. That's it, all right? Then for port B, you see pin 0, 1, 2, 3, 4, 5, 6, 7. But pay attention, on the chip is pin 45, 46, 47, 48. Then jump to 58, 57. Then come back to pin 1, pin 4. All right. So pay attention, they are not the aligned in sequence, okay, increment by 1. Sometimes they jump the number, but it's okay, all right, to you, because we have this table. This is just for you to know in case if you want to do the soldering, you must refer to this table. Okay, good enough. Okay, and then you see all the pin you can access. Okay, package the input output pin. All right, but in this context, we only care about the output. You see, because it is a general purpose input output. You can use also today's content to implement last week's application to interface with your sensor to read the data from your sensor. All right, okay, it's the same. Then you see also you can do the interface with analog sensor, because here you see we have an input which can take in analog value because we have a built-in AD converter, right? So you see the presence of analog to digital conversion, all right? Okay, then how to operate general purpose IO? So actually it's quite easier. So you must configure all these register for input operation, configure internal process, configure output operation. Then for input related operation, then for today's lecture, not much relevant because our intention is what to output, okay? But pay attention, just at the beginning I mentioned, when you play with the actuator, safety is an issue, all right? Because the actuator can kill people, it's dangerous, all right? So always has some safety measure. In particular, have a special button. Once I press the button, then stop everything. So button is an input device. Once you press, then the button is on or off. You must keep reading. Once I read in, this is the emergency button which has been pressed, okay? But it tells me something is wrong. Then I must stop everything, all right? So you still need to have an input of an urgent signal from the user, from the environment. all right? So this could be a person, I press a button, or could be a sensor tell you something is wrong, must stop the operation. Otherwise, there's a big accident or whatever. Just keep this in mind. So therefore, we still need to have an input, little bit important signal for safety issue, right? But of course, our intention is to output something, right? Output the digital signal on for how long duration and off it, etc. Right? Okay. Then configure input. Let's say some urgent signal for us to stop some operation, because all the pin from all the 6 port could be input operation. Then you must first to see whether I turn on all the 6 port or not. So here you see a port, you see 0 to 6. So you have a 6 signal to turn on all these 6 port, okay, for either input or output operation. First, turn on the port, okay, which involve in the input or output operation. So that is a straightforward, okay? So it's quite easier to understand. Then for internal process, right? So then, because once you turn on all the port, then you need to tell people for each port, you have a pin, whether all these pins are involved in input operation or output operation, all right? If it's input, you must tell here, because you can mix for same port, some pin is for input, some pin is for output. Then is here you tell, okay, 0 maybe input, 1 is output, because you see, now you see you have how many port and 6. Here you have 2 address. This is just for you to know is the power of this microcontroller. So actually you have 2 address bus, okay, inside the ARM microcontroller. So that allow you to avoid the collision of the data. It's like you have 2 highway between like Beijing and Shanghai. Once you have 2 highway, then the traffic situation will be better, right? So that is this situation, all right? Try not to feel it's complicated. No, it's an advantage, okay? So you can choose either one, up to you. It's like you have a 2 highway link Shanghai and Beijing, and which highway are you going to take? It's up to you. You decide. You should not consider this is a drawback or it's a headache. Okay, how come there are 2 highway? Why not just 1 highway? Then I do not need to think. If there's a 2 highway, then I start to think which highway to choose. All right. But this is an advantage, consider it. Don't consider it as a drawback, all right? So this is the same situation, okay? So you have a 6 port. Each port gives you 2 way to 2 address bus to open the port in order to configure it, right? So you have 2 address bus, all right? So then each port has an A pin. Then each pin you may tell whether it's input, output, etc. Okay, so like it. And why we still need to have an input? Just now I mentioned the emergency. Okay, if something goes wrong, press a button. All right, here is a keypad. Or you press a keypad, then the machine will stop. Or you press a keypad, tell the machine a specific requirement. Then you can press a number, a series of number. Then your microcontroller know what is your intention, right? So just for you to know this, okay? And once you, okay, this one is to enable. That means for each port, once you select the port, then for each pin, you can just enable, disable it, all right? Or use it or turn it on, turn it off, like use it or don't use it, all right? And is this one tell the direction? Okay, what is the input? What is the output? If it's a keypad, it's for input, okay? For motor, is the output. So you see, it's very flexible. That means you choose among all these 6 ports, you can choose all of them. Then for each port, you can choose all the pin or some of the pin, all right? Then for the pin chosen, you must decide what is the input, output, 3 steps. Okay, choose the port, choose the pin, decide direction, okay, of the direction of the flow of data, either flow in or flow out, all right? Something like that. Okay, this is the direction of a flow of the data, all right? And in case it's a flow in, it's like I press a button, something is urgent, stop everything. then you must tell whether my brain will respond it when I see there's a level change or when I see there's an age, rising age, falling age, or level high, level low. You see, okay, you must tell, okay, how do I respond? Should I respond to the level high, level low, or transition from low to high, or transition from high to low? Okay, so here is to choose whether respond to the change of a level or change of age, all right? Okay, once you choose response to the level, then you must tell whether it's level high or level low. If it's level high, I take action. Level low or take action, all right? Okay, so if previously you choose respond to the age, then this one tell whether you respond to the rising age, transition from low to high, or falling age, transition from high to low, all right? You must combine these two together. And okay, here say you must combine the previous two register to achieve this goal, response to which, because here you see you have a four signal, four specific meaning of the input signal, then response to which one, all right? For some application, you may say, I don't care which age, as long as you see the rising, falling, immediately response is urgent, all right? Okay, then you say, okay, here say response to both age, all right? Tell the hardware, all right? So that is for input. In the context of the motor control is important because once you press the emergency button, must respond stop everything, all right? Okay, and okay, then this is once you define all these signal, okay, for some time dynamically, you may say during certain period of time, I'm doing a certain type of activity, then don't interrupt me. Also, you produce active signal at the input of the port. I mask them out. Is here. You can dynamically say, okay, don't pay attention to this signal. All right. So this is the interrupt mask. Interrupt, you remember, is a signal. Then in this case, is a signal detected by the input pin. Right. Also, you have tell the hardware response to what kinds of signal, and here you can mask them out dynamically. Depends on this period of time. I'm quite safe. I do not want to be interrupted by external signal. That's it. So you can do it. So you see, it's very, very flexible to you. Another thing is when you operate your motor, sometimes you may want to know, I have to turn on this motor. How do you know? Okay, how to tell user this motor is on? It's always good to light up LED channel. Okay, but good news to you is and this pin they can serve as a current supply. If let's say you can connect an output device, which is not take action, but just indicate the status, like turn on the light LED. So then the good news is you can supply current 2 milliampere, right? So then if let's say your LED can light up with a 2 milliampere, then you just connect here and set the one in this register. For some application, I may want the 4 milliampere. Then for some application, I may need the 8 milliampere. Then you see the register is different. So you just turn on, then you do the connection, all right? So you see, you are very flexible. Either power on LED display to indicate this motor has been turned on. So then as an inspector, like just take a look, when this light on, then you see our motor has been turned on. That's it. You see, very, very powerful microcontroller, right? And this one is to make a very reliable communication or reading the data, send out the control signal, right? So because you know, okay, if I do not send out the signal, because it's very dangerous for motor to respond to the false signal. If they say, I did not send out any signal, suddenly how come my motor can respond to it? Due to noise in the environment. Then how to prevent such a noise happen? So this is the setup, okay? So you may see, okay, that means to turn on this register, right? So therefore, then the current can only flow in open jam. Jam means just like singular, okay? Just take in, it's not the source. Source is output, right? So once you turn on it, means the current can only flow in, can never flow out. So that means this pin will not trigger action from the actuator, something like that, all right? Okay, so then current only flow in, right? So this is for safety. Then once but this is for once you turn on for certain period of time dynamically, then after that you must off it. If they say I want to output a signal, so then this is also for safety. If they say I do not output anything, the signal line will flow there. Depends on the noise. Sometimes could be 3 watt or 2.7 watt. That may interpret by your motor as a 1, turn on the motor. That is dangerous, right? So how to prevent that? So you may have a convention. If I do not send any signal, the output is always 1. How to do it? Then turn on internal pull up resistor. Pull up to 5 watt. Pull up to 5 watt means I do not output anything, then output either line. I mean, by default is always 1. All right. For some application, you may say, by default, if I do not tell you to do anything, this line must be 0. There is a pull down register, always connect to the ground, right? Whenever there's a noise, then current flow into the ground, it's always 0. That is for safety, because remember, when you control the motor, it could be dangerous. If suddenly your motor turn on without the intention of the microcontroller, then it's accident channel, right? So you can feel this is a very reliable machine, right? A microcontroller, right? Okay, something like that. And once you configure it, this is another safety. Prevent the hacker, let's say your internet, people hack into your hardware, change your modification, make your system become unreliable. How to prevent that? So you have a lock mechanism, right? So once you write something here, then you will do the update. If you also you show your intention. If you do not write the 111 here, then whatever is the change of a configuration will not take effect, right? So you must tell, okay, I want to, after configuration, okay, update the configuration, right? And this register could be locked, right? After that, I lock it, okay? Once you lock it, regardless of how you change, it will not take effect. Then how to unlock it? So you must write this specific number. You see, nobody can remember. Must write this number into this register, okay? Then you can unlock it, all right? By default, you write something to lock the register. To unlock the register, you must write this specific number, all right? So that prevent any people to hack into your IoT, modify the configuration, and make your actuator to undertake a destructive action. Now you see, this is very secure channel, right? Okay, so this is extra knowledge for you to know. Then output configuration, that is relevant to the control of a motor. But basically you need to output, let's say transition from 0 to 1. Then for this 1 lasts for how long? So basically it's like a motor will move 1 step, okay, last for how long, then, okay, then move another step, right? So then is your software to control it. So you just need to know whether I'm able to pull a line, okay, to be 0 to 1 or not. The output is symmetric because you have how many ports for, you can use all the ports for all output. So then you select all the 6 ports for all output, right? Same, right? So you choose the port for output, you have a 6, right? And also you must do the same thing for each port, each pin, whether input output operation, or how many pins involved in the input output, then what is direction for each pin is the same, right? After that, okay, then you run. Run means that is then your program. Like assume in this case, okay, let's say pin number 1 from port A, okay, I must produce a positive pulse, right? Then make a transition to 0, 1. So basically you just write the 1 here, send out, right? Immediately the pin, there's a 1 here, okay? bit 1, you write the 1 here, all right? Then the corresponding hardware pin will be logic 1. Then logic 1, you remember, after that, you connect to an electronic switch. Then that switch is switched on, then the power, the current will flow inside your motor already. So it's very simple. So first lecture is important. Basically, the microcontroller for one phase just output 2 signal, because one phase you have 2 N, right? So and you just output 2 signal. 2 signal means without the hardware support. With the hardware support, just 1 signal will do. All right. So okay. And then here if you have a 10 motor, okay, for stepper motor is a 2-phase. Stepper motor is a 2-phase motor. And you remember we can have a 43 pin. That means what? You can have, okay, without the hardware support, then you can control 21 stepper motor. Right, it's a lot. All right, okay. Then you must know all the connection. Then you, at the same time, you activate 21 motor, stepper motor. Right, it's a lot. Right, and okay, here is another safety issue. It's very interesting. You look at the address here. Do you see all the last 3 number is 000? So this is a hexadecimal number. 1 digit of a hexadecimal number correspond to 4 bit of a binary number. All right. Then 3000 in hexadecimal tell you that they are 12 bit. 3 times 4 is equal to 12. It means inside the address, 12 bit are not being used. Then the designer is very smart. Then we can make use of this 12 bit to select. It's a final selection of the data bit which will flow in, flow out. Then this serves as a security encoding to make your system is even more secure. Because when people hack into your hardware, there's no way for him to know, because you hide your security coding inside address. Now you see the power of this. So really now making you believe is you pay a price of bicycle, you get the sport car. Here is one more example. You can hide your security code inside the address, because here we do not use the first 12 bit. That is the trick, all right? Then you see, and another thing is the encoding for security, a selection of the final bit of data which are allowed to flow in, flow out. Start from bit 2 to bit 9. It's not start from bit 0 to bit 8 or bit 7. It's 8 bit, okay? So it intentionally do a shift. Even you want to guess out the, you must know, this encoding bit selection from bit 2 to bit 9, right? Then inside this 8 bit, when you put the 1 there, that means the corresponding bit inside the data bus could flow in, flow out. Otherwise, will not take part inside the input-output operation. So here you see output. So also you have a data, and if the bit is not allowed to flow out, it will never flow out, all right? So only the bit which are allowed will flow out. Then how could the hacker, okay, hack into your IoT, know all this information? Very difficult, all right? So you see, with the use of ARM microcontroller, you can implement very secure IoT. Then for the sensory data to flow in is the same. You see, you can also specify what are the bit of the data which is allowed to flow in. Okay, if it's not allowed to flow in, you will not receive the data. Then you see only those bit, okay, corresponding bit you inside the address, you have a 111. Then this data bit from the sensor will be allowed to flow inside your microcontroller. You see, this is another tremendous advantage or option for you to implement security inside your hardware, right? Because nobody can guess out, right? In your hardware, you are doing this. Okay, this is one more example showing you. For example, if I have a sensor connect in port F or actuator connect in port F, then I can use okay, address data for the, let's say, to know, okay, whether I allow the data bit which are connect to port F, because port F have only 8 pin, pin 0 all the way to pin 7, right? And some of the pin will be allowed to flow in, flow out the bit, and the rest will not be allowed. For example, how to allow the data bit connect to pin 0, PF0 to flow in? Now you remember in the address bus should be the bit number 2. Okay, so this is why it's very tricky. But tricky is difficult for your hacker to hack into your code, right? So it's a bit 2 means it's 0, 1, 0, 0. Okay, bit 2 is 1. Then in hexadecimal number is what? Is 4. You write the 4 there. That means I only allow the data bit connected to pin 0 port F to flow in, flow out. How's about the data bit connect to the pin 1 of a port F? Then you must write the A in this A or 0A in hexadecimal. In binary number should be 100. All right. So then you see, if let's say I will only enable the data bit connect to pin 2 port F to flow in, flow out, then you must A in this 10 hexadecimal. 1 corresponds 0001, and the 0 means 0000, all right, etc. But you can mix them together, all right? If let's say I allow the data bit connect to pin 1, 2, 3 to flow in, flow out, then you must write the 38, 3A or 3A too. Okay, this just give you more detailed explanation, all right, of the previous slide. Okay, in case if let's say 3A correspond to what? 3A correspond to the selection or pin data bit connect to pin 1, pin 2, pin 3 of port F, right? That's it. Okay. And after that, then just run. Once you run, actually you can monitor internally generated signal, right? And for example, whether the input has data appear or not, because once you press the button or not. So here basically showing you internally generated signal by the input device, etc., right, etc. And then if you mask out some internal signal, then you can still check, okay, what are the interrupt which has been masked out by the configuration, but they are still there, right? Something like that. And how to clear all these internal signal, you must write one to clear them. So this is quite standard one, okay? So then if you have a hardware, you can follow this connection diagram to practice. And then you see, we make use of a port A, port B to do the connection. And even for port A, only pin 4, 5, 6, 7 involved. For port B, pin 0, 1, 2, 3 involved. Then you know how to enable port A, and for each port, then you choose the pin which involved in the input output, right? Something like that, okay? And even for port D, then you see, this is a typical example control buzzer. Buzzer is also an output device instead of a motor, right? Only pin 0, 3 involved, right? Okay, so that's all for the way how to interface with stepper motor. So you remember, stepper motor is considered as a two-phase motor. Each phase has a two connector. Each connector eventually need a pair of electronic switch. Like each phase you need 4. In total you need 8. Okay, but with the hardware support you need 4. Without the hardware support you need to have an A signal. All right, so that's it. But all these concept equally applicable for you to control continuous motion motor, right? So it's the same, but we are not going to repeat it. Then in lecture 3, we just study a special purpose I/O dedicated, for producing PWM. You can also use that to control stepwise motor and also continuous motion motor, right? So we take a break of 5 minutes. We start at the 4:40, right?